Good evening, students. So in the previous video we discussed about IUPAC's nomenclature of some compounds including benzene derivatives. Up to in NCERT book, up to this problem we discussed in the previous video. That video link I will give this video description, so you can uh, see that one. Now the other topic is isomerism. In isomerism, we have to discuss some points like what is structural isomerism and what is stereo isomerism. So first of all, what is isomerism? Isomerism means the phenomenon of existence of two or more compounds possessing the same molecular formula but different properties is known as isomerism. That means if a one compound is there which is having some molecular formula, and the same molecular formula is possessed by another molecule also. So these two molecules are different but having the same molecular formula. For example, here if we have C2H6O, so this is one molecular formula, and now this is possessed by two compounds. That means like CH3, CH2, OH. This is an alcohol which is having OH functional group, and the same molecular formula belongs to this compound also. This is ether, dimethyl ether. This is alcohol. Both are totally different. This ethanol, this is called ethanol. This is having boiling point around 70. Not exactly, but around 70, nearly. But this dimethyl ether is having boiling point around 30 or below 30. So that means both are totally different but having the same molecular formula but different functional groups. This is OH functional groups, this is ether functional group. So both are totally different. So they are having the same molecular formula. Therefore these two are called isomers. That means functional isomers, and this phenomenon is called isomerism, functional isomerism. So here structure means isomerism is two types. Let us see the classification of isomers. Isomerism is two types. So here this is isomerism, and it is having structural isomerism and stereo isomerism. Structural isomerism means in the molecule structure is different. Just now I have shown you, one is OH structure, another one is ether structure. So both are totally different. So having the same molecular formula but different in their structures are called structural isomerism. Here stereo isomerism means they are having same molecular formula, same structural formula also, but difference in the arrangement of their atoms or groups. Difference in the arrangement of atoms or groups. That means in the space, in three-dimensional space, the arrangement of atoms or groups are different. That means one isomer is having means one side one type of atoms, another isomer is having another side that kind of atoms. That we will discuss in detail when we come to stereoisomerism. But here structural isomerism is again four types. The structural isomerism is again 4 types: chain isomerism, position isomerism, functional group isomerism, metamerism. 4 types. And the stereo isomerism is 2 types: geometrical isomerism and optical isomerism. These two we will discuss when we come to that particular topic. First, let us see what is structural isomerism. In that, what is chain isomerism? So here example is given, chain isomerism. So here if you see, this is pentane. It is having 5 carbon atoms. Let us remove that. So here if you see this is pentane, and if we write a bond line formula for this pentane, it will be like this: 1 2 3 4 5. This is bond line formula for pentane. And if I write one methyl group, this is what is the molecular formula for this? C5H12. That means 5 carbons are there and 12 hydrogens are there. So how to count the hydrogens, how to count carbons in bond line formula? So if you go to previous videos, you will understand how to write bond line formula for a given structural formula. So this is called structural formula, condensed structural formula, and this is called bond line formula. So if I write one methyl group, this one, and I am writing methyl group here, one methyl group. This is also C5H12, C5H12 only. This is also C5H12. This is also C5H12. Okay, and here one more is given. One more is given. This one is also C5H12. C5H12. So this is straight chain compound. This is called N-pentane. N-pentane, normal pentane. This one here second position methyl group is available. That methyl group is available, but having the same molecular formula. So this is isomer of chain isomer of this one. That means this is 2-methyl butane. The name of the compound is 2-methyl butane, and this is N-pentane, and this is 2-methyl butane. Both are having molecular formula C5H12, but in the chain it is straight chain. That means in the single way chain is available, but this is having one branch here, methyl branch. So this is 2-methyl butane, this is N-pentane. Both are chain isomers. And one more thing here, one more isomer is available for N-pentane, that is called neopentane. That means at second carbon, this carbon, 2 methyl groups are branches are available. That means 2,2 dimethyl propane it is. 2,2 dimethyl propane, which is also called neopentane. Neopentane. So this is N-pentane, this is 2-methyl butane, this is neopentane. 3 are having the same molecular formula C5H12, but they are differing in their chain, carbon chain. So those are called chain isomers, and this phenomenon is called chain isomerism. Okay, and the next one is position isomerism. In the structural isomerism, the next one is position isomerism. That means in position isomerism, let us see what it gives. Here propane 1 mole is given. That means 2, 3, this one. So this is 1, 2, 3. 3 carbons are there. So it is called 1 propanol or propane 1 mole. and this hydroxy group, alcohol group, if I rate at second position, this one, this is called 2-propanol. 2-propanol. So this is 1-propanol, this is 2-propanol. Another name is propane 1-ol, propane 2-ol. So hydroxy group is at first carbon, hydroxy group is at second carbon. That means position is different. It is at first carbon, it is at second carbon. So position is different, but having the same molecular formula. That means isomers which are having the same molecular formula but differ in their position of the functional group or position of the chain, position of the functional, mainly position of the functional groups are called position isomers. And the example given are 1-propanol, 2-propanol. Okay, actually this methyl group is, this OH group comes here, this carbon, not this carbon, but it comes this second carbon, that is 2-ol, propane 2-ol. Okay, this is position isomerism. Let us see what is functional group isomerism. Just now previously when we start this video, we discussed about ethanol and dimethyl ether. Ethanol and dimethyl ether. Let us write that one. Yeah. Functional group isomerism means here what is given, C3H6O. C3H6O. That represents CH3, CH2, CHO. This is CHO. This is propanaldehyde. Propanaldehyde or propane 1-ol. That means one. That means propanol. It is propanol. Propanol aldehyde. This functional group is aldehyde functional group. It is having molecular formula C3H6O. 3 carbons are available, 6 hydrogens are available, and 1 oxygen is available. It is propanol. If I write CH3, CO, CH3, this one. This one. It is also having molecular formula C3H6O. C3H6O. This is also having C3H6O. This is also having C3H6O, but it is aldehyde. This is also having C3H6O, but it is ketone. C double bond O is ketone. C double bond O. This keto group. So having the same molecular formula, but difference in their functional groups. This aldehyde functional group, this ketone functional group. Difference in their functional groups. This type of isomerism is called functional group isomerism. Functional group isomerism. So therefore, these two are functional group functional isomers. Okay, so that is functional group isomerism. Okay, now let us go for one more example for functional group isomerism. Suppose we have this ethanol, just beginning of this class I gave you ethanol. Molecular formula is C2H6O and dimethyl ether TH3O CH3. So this is also having C2H6O. This is also having C2H6O. So this is alcohol functional group. This is ether functional group. So both are functional group isomers. So alcohols and ethers are functional group isomers, and aldehydes and ketones are functional group isomers. Okay, that is functional group isomerism. Now let us go for metamerism. Yeah, here structures are given: propanol and propanol. So these two are aldehyde and ketone. Both are functional group isomers. Next one is metamerism. Metamerism means, suppose we have this methyl group. Here oxygen is there, here, here, here. So this compound is available. What is this compound? What is this compound? This is called methoxypropane. This is methoxypropane. Methoxypropane. If I write this compound, this is ethoxyethane. Ethoxyethane. This is ethoxyethane. This is methoxypropane. Both are having same molecular formula, but difference in the position of the oxygen. Here oxygen is at second position, here oxygen is at third position. This is also ether, this is also ether. Either functional group, either functional group. But here the position of the oxygen is different. That means this is methoxypropane, this methoxy, here 3 carbons, propane. Here it is ethoxy, this side 2 carbons, so ethane. Ethoxyethane and methoxypropane both are called metamers, and this phenomenon is called metamerism. This phenomenon is called metamerism. So that's how metamers and metamerism examples are shown. Okay. Yeah. Now that is about structural isomerism, chain isomerism, position isomerism, functional group isomerism, and metamerism. We have seen the examples. Now stereoisomerism. This is stereoisomerism. This stereoisomerism is two types. One is geometrical isomerism, second one is optical isomerism. First let us see what is this geometrical isomerism. Geometrical isomerism means, suppose we have CH3, CH double bond, CH, CH3, CH3. That means it is just like let us write once again. So it is this is here CH3, here CH3, here double bond in between, and here CH, here CH, CH3, CH, CH, CH3, and I can write this in one more way. CH3. So this is also same. CH3, CH, CH, CH3. This is also CH3, CH, CH, CH3. This is also same. CH3, CH, CH, CH3. But here across this double bond, this CH3 is above, this CH3 is below. But here across the double bond, this CH3 is below, this CH3 is also below. That means here both the CH3s are one side, but here both the CH3s are opposite sides. So this is called, this one is called trans 2-butene. This one is called cis 2-butene. Cis 2-butene. This one is called trans 2-butene. This one is called cis 2-butene. When both the groups are same side, that is called cis isomer. When both the groups are opposite side, that is called trans. So like this, cis trans isomerism existed, and this is also called geometrical isomerism. Geometrical isomerism. That means when double bond is there in a compound, the double bond is not having free rotation like single bond. So groups are fixed across the double bond. So this methyl is fixed above the double bond. This methyl is fixed below the double bond. So this is called trans isomer. This methyl group fixed below the double bond. This methyl group is also fixed below the methyl group, below the double bond. So this is cis 2-butene, this is trans 2-butene. Both are having same molecular formula, same structural formula, but difference in the position of their methyl groups in the space. That means here both methyl groups are opposite direction in the space. Here both methyl groups are same direction in the space. So same molecular formula, same structural formula, but difference in their arrangement of atoms or group is called stereoisomerism, and this type of isomerism is called geometrical isomerism. So that is geometrical isomerism. Cis 2 between trans 2 butane. Examples. Now let us see what is optical isomerism. What is optical isomerism? Optical isomerism means we have a machine called polarimeter. Polarimeter. That you remember, polarimeter, a machine. So this machine should be remembered for this optical isomerism. So like some machines are available in the chemical laboratories or institutions like universities and degree colleges or PG colleges. This polarimetry is available where optical activity of a compound is measured. What is this optical activity? Optical activity means, so here this is called methane. Methane. Okay. So now if I remove these 4 hydrogens with 4 different groups, like the same carbon I am writing here, the same carbon I have written here, but for one hydrogen I am writing here the same hydrogen, and here I am writing one bromine for another hydrogen. Here I am writing CH3 group. Here I am writing CH2, CH3. What I have done? Here 4 hydrogens are replaced by 4 different groups. That means one hydrogen I kept as it is. Another hydrogen I replaced with bromine. Another hydrogen I replaced with methyl group. Another hydrogen I replaced with ethyl group. Ethyl group. So this carbon is having 4 different groups. Here this carbon is having 4 same hydrogens, but here on this molecule it is 2-bromobutane. This compound is called 2-bromobutane, and it is having the carbon 4 different groups. That means hydrogen, bromine, methyl, ethyl, 4 different groups. So this type of molecule where carbon is having 4 different groups is called asymmetric molecule. asymmetric molecule. And the carbon which is having 4 different groups is called chiral carbon, and it is denoted with this star mark on the carbon. So this carbon is called chiral carbon. Chiral carbon. And this molecule is called asymmetric molecule. Asymmetric molecule. So molecules which are asymmetric in nature and is having chiral carbon, when this type of molecules are kept in the polarimeter, there is a provision to keep the solution of this molecule in this polarimeter. Then this polarimeter generates one light called plane polarized light. Plane polarized light. Plane polarized light. So in our homes and all, tube lights are there, bulbs are there, they generate normal light. But this polarimeter is having special provision which generates plane polarized light. That means, what is plane polarized light? It is having it travels only in one direction. So our light, normal light, travels in all the directions, but this plane polarized light travels in only one direction. That's why it is called plane polarized light. It is having a fixed means direction, a fixed direction. When that type of light is falling on this molecule, then the direction of that light changes. Because it is having chiral carbon, the direction of that light is changing. That means, if it is having this direction, that light is having this direction, when it passes through this molecule solution of this molecule, then direction changes like this. Direction changes from this to this, or this type. Okay, let us see. This is the direction of the light, initial direction. Then this will change either clockwise direction or anti-clockwise direction, like this. This is anti-clockwise direction, this is clockwise direction. If the light changes clockwise direction, then this isomer is called dextroisomer, denoted by D. When light is plane polarized light is passed through this compound, another light changes its direction to left hand side, that means anti-clockwise direction, then this isomer is called levoisomer, L. So clockwise direction means D, dextroisomer, DEXTRO. When it comes to left hand side, anti-clockwise direction, that is called levoisomer, levo. So if this compound rotates that plane polarized light to clockwise direction, then the mirror image of this molecule, that means this molecule here is kept just adjacent to one mirror, and how the mirror image appears in the mirror, that molecule, that structure changes the plane polarized light to left hand side, that means anti-clockwise direction. That means if this compound is dextro, then mirror image of this compound is levoisomer. So two isomers will be available whenever carbon is having asymmetric center and that particular compound is dextroisomer, that means rotating plane polarized light to right hand side, then its mirror image, here mirror image rotates the plane polarized light to anti-clockwise direction. The isomer which rotates plane polarized light to clockwise direction is called dextroisomer, and the isomer which rotates plane polarized light to left hand side, that means anti-clockwise direction, is called levoisomer. Okay, so this phenomenon where two isomers are having same molecular formula, same structural formula, but their mirror images are rotating plane polarized light in opposite directions. One is clockwise direction, another one is anti-clockwise direction. So these two isomers are called optical isomers. Optic means light. So plane polarized light, they are rotating in different directions. So there only difference is there. Remaining everything is same. That's why they're called optical isomers. And this phenomenon where plane polarized light is rotated by one isomer right hand side, then its mirror image left hand side, is called optical isomerism. Called optical isomerism. So let us see how the mirror images appear. So here, okay, just a minute. Here carbon is there. Here one group A, here one group B, one group C, here one group D. This is dextroisomer. Suppose this is dextroisomer. Here mirror is available. Mirror. Here mirror is available. Then its mirror image is like this. Carbon A will be there only, but D will be this side, and C will be like this, and B will be like this. These two are mirror images. These two are mirror images. If this isomer is dextroisomer, then this isomer is levoisomer. Levoisomer. So these two are having same molecular formula, same structural formula, but only in their arrangement of atoms in the space differently. So they both are mirror images, and these two mirror images are called enantiomers. Enantiomers. Combinedly, these two mirror images are called enantiomers. Okay, so this is means dextroisomer, this is levoisomer, and this phenomenon where optical isomers, both isomers rotates plane polarized light. If one isomer rotates right hand direction, that means clockwise direction, its mirror image rotates anti-clockwise direction, plane polarized light. This phenomenon is called optical isomerism, and these two isomers are called enantiomers or optical isomers. Okay, this is called optical isomerism. So this is not given this much depth here in this textbook. Only this small paragraph is given about stereoisomerism, but we need to know what is this geometrical isomerism examples, what is this optical isomerism examples, we need to know. So we discussed all these points here. Therefore now we have completed isomerism topic, and in the next video we will discuss about fundamental concepts of organic reaction mechanism. Till then, take care. Bye.